So we've taken QFabrics and we're testing it in our center because we want to understand how this is going to help us to meet our scientists' needs. So we put it up head-to-head against one of our supercomputers that we've had. We've spent a lot of months tuning it and getting applications to run well in our supercomputer center. These are production applications. These aren't synthetic benchmarks, right? So this is what our scientists really care about. They don't care how fast ping pong goes. They want to know how fast their application's going to run. So 100% line here means you're at parity with our supercomputer. In this case, within about a month and a half of testing, we realized 2 of the benchmarks actually exceeded our supercomputer. Most of them are running somewhere around 90% of what we can build with something other than Ethernet. And we haven't even begun to strip out some of the features of Ethernet that tend to get in the way of latency. So this is still running with TCP, the same protocols that you would use across the internet. So we're really excited to see just how far we can push this. And with Juniper's permission, we're going to be publishing future numbers as well and just see how far we can take it.
As you know, we've been on this journey with a smarter planet for the last couple of years. And it's really important to think about what does it really mean to be a smarter planet. So we believe that smarter planet is really one that is instrumented, interconnected, and most importantly, intelligent. Because after all, being smarter means that you're more intelligent. So what does this really mean from a computing perspective? Like, how do we really think about this? Well, we really think it helps organizations do things faster, better, and at more effective cost points. And as you can see also from a smarter networking infrastructure, this is key to also being smarter in your data center with your ability to unite business and IT, streamlining costs and accessing services and resources more efficiently. This is key to building a smarter planet.
So what are we looking for? First of all, we wanted to get rid of the 2 major networks in our data center and combine them. We have a separate network. It's called storage. It runs on that fiber channel. It's run by a couple of other companies. The problem is it's a complete independent network that's almost in size and certainly in cost the size of our main data network. Is there a way we can start to bring these 2 together? We need that. We also need to support bandwidth on demand. My bandwidth curve is not slowing down. Pick your favorite number. Somewhere between 15 and 20% compounded growth per year is what I've seen over the last decade and a half, almost 2 decades now. So it hasn't let up regardless of market conditions. Critical to us is very low latency and very low jitter. You can see people talk about the race to zero latency for an execution. It's been in the papers and you hear a lot about it. That race started somewhere around 1750. And that's when we started with it. It really got going in the mid-1800s with the telegraph, well, pardon me, Pony Express, telegraph, telephone. Each one of these was a revolutionary step in speed. The downtown ticker network that was deployed in the 1880s was put there because the runners couldn't run across the street fast enough to report the market prices. That's why we did it. And the race for lower latency has been on since then. So traditional Ethernet, when you normally build a network, you build it up of cute little boxes, Ethernet in, Ethernet out. And that's okay, and it's worked good for very small data centers, and it's worked good when you're doing 100 megabit and maybe even gig. The reality is this is not a good solution. It's a bad building block. It does not scale. I wind up having more ports interconnecting the boxes than I have doing something useful for me. We have to break that model. The way to break it is the phrase I use, not quite the same one as David and Pradeep, is take a router and explode it across the data center. Give me one large router, blow it out, throw the line cards in the tops of my racks, give me one switching fabric, I'm done. It looks like one seamless router, and I'm a very happy person. That's the product we're looking for. That's where we're taking the technology, and that's what we have to do over the next several years to go forward.
So we see this data center, the topology evolving, right? We've got to get rid of this application-based silo approach, whether it's the physical instantiation of it or the mental instantiation of it. I need that server to be connected to that particular piece of equipment. That's outmoded thinking. We're clearly seeing the widespread adoption of virtualization. We partner with VMware. They're here as well. And now, obviously, that's transforming to both internal and external cloud services. And you're going to see enterprises that adopt some combination of both and have them interoperate. But the bottom line is companies are looking for a single infrastructure to support multiple workloads, multiple applications, multiple departments, multiple customers, but on a common secure infrastructure.
So this infrastructure transformation in turn imposes a whole new set of requirements on the network. Any-to-any connectivity, the ability to take an application that's pieces of an application where one virtual machine might be living on a rack number 1, row number 1, another component of the application running in a VM on the other corner of the data center, and have them seamlessly networked or moved around without having to disturb the underlying network configuration. The ability to provide elastic resources as and when the network applications need more network resources or compute resources to provide them on demand. And then certainly, last but not the least, to provide a multi-tenanted segmented infrastructure